because I can then tell Joan that you did this test and you got this result, and you know you're trying to improve and you're doing extra stuff. Do you know what I mean?
It looks good.
It looks good, in other words, yeah.
But what if I do bad in this test?
Then I won't tell her. Is that what you're saying?
I probably will do bad.
Yeah, okay, well look, if you do well, I'll tell her. And if you do poorly, I won't say anything, because you're just doing this for extra practice.
Well, look at
So I don't want to discourage you from doing it, you know? So if you do well, I'll say, oh, Ray did a great job. But if you don't, we'll just forget about it then.
Look at it like you still went home and tried a test and you didn't have to do.
Yeah,
It still looks good even if you do bad. Your teacher.
yeah, she's right. Like, John would still be happy that you're making this effort, you know? So anyways, if I was you, I'd do it. That's my point. Yeah. Okay, so the first question here, I ask you, I'll just do a random example, like we'll just say, I'll just say 1D. So you have log base 9 of x equals 2. So my question here is, what values of x can you use? So Michelle, if you look at this one here, 52. Yeah. Michelle, this question here, what values of x could I use? Or in other words, what values of x am I not allowed to use? Whichever way you want to think about it. Yeah, can I or can't I use them? Can't, okay. And is there anything else I can't use?
For nothing to go to negatives.
Just the negatives, yeah. There's Ray or Sabrina, is there anything else that you could not use here for x? So Michelle correctly said that x can't be negative. You can't have the log of a negative number.
So what we're trying to find here is what log 9 and then the top.
No, it's not even as hard as that. I just want you to tell me what values x could possibly be.
So I'm seeing what the end game is here. Like we're trying to find what x is that would make that equal to.
It would be, yeah.
Okay.
Yeah. But we're not even asking for that. We just want to know what values of x could it possibly be. So Michelle, you said it can't be negative. That's correct. Anything else it can't be?
I think it could be a...
It could be a fraction, that's okay, yeah.
Could be a 3.
Could be. Oh, do you
Asking like.
mind getting that? Oh, thanks Sabrina. No,
I think, did you find it?
Yeah.
where was it?
On the side.
Ah? Now you can think about your maths.
Yeah.
Yeah. Okay, so anybody else? So it can't be negative, but there's something else it can't be.
The 0?
Can't be 0, yeah. So the answer here is x could only be positive. That's all I want you to do. So the question here is, what values of x are allowed? You could say it like that. So are you allowed to use 0? You're not. Are you allowed to use negatives? You're not.
So you would want us to write x.
Just this. Yeah, just this. That'll do. Don't be angry, but I forgot your name. Well, I didn't forget it, but I have a couple of possibilities in my head. So it's either Mariam. No?
Yeah.
Oh, good. All right. No. Okay, good. Good. I was only 90% sure. I wasn't 100% sure. No, true. Okay, 2D. 2 power x equals 6. Okay, now we're starting to get into the more interesting ones. Okay, Ray. Well, you're not sure that you've actually done this.
I have not done this.
You're now sure that you haven't done this.
No.
Okay, all right. So we'll ask the Mariam, Michelle, or Sabrina. Would you know what to do next to try and get the x here? No. Okay. Yeah. What do you think? Root. Nice try, but not root, I'm afraid. Or divide. Sorry. Any other ideas, Michelle? Any ideas? Yeah, no, that's fine. You're thinking about the previous lesson, where you're right. No, you're right. It has to be the same base. So if you had 2x equals 8, for example, then you can change 8 into 2 cubed. Yeah. But the problem here is that you can't make a common base here because you can't change 6 into 2 with a power. Because 2 power 1 is 2, 2 squared is 4, 2 cubed is 8, so it's not possible. Any other ideas? No? I'll give you a clue. It's the name of the lesson.
A log.
A log is needed here, yeah? So, we'll put a log on the left and a log on the right. Have you heard of log before? Yeah. You have it on your calculator, this log button.
I think so.
Yeah. Have you got your calculator with you?
No.
No. Did you have it?
I did.
And what happened to it?
I left it in my room.
Okay, alright. Right, now that I've done this, Michelle or Mariam, any ideas? What's the next step?
Put it in your calculator.
We could put this one in, but we can't put this one in because we don't know the x. Not yet. There's a step before that. There's something before that, before you divide. It's something to do with the yeah. You said divide by log 2.
Yeah.
I said not yet. There's something to do before that. Yeah, Michelle, you have an idea? No?
You bring the x.
Yeah. You bring the x down. Yeah. Now, if you look at your rules of logs, that's one of the rules, that you're allowed to bring powers down in front. Yeah? Do you have your rules handy if you want to check? It's like the 4th rule or the 3rd rule or something. Yeah, it's the 3rd rule anyways. Okay, so now, Mariam, what do we do next? You suggested it.
Divide by
Yeah, so you have log 6 over log 2 equals, and then we can put that in the calculator.
Also, Alfred with the column.
Oh, is she in trouble? Or is he in trouble? Which way around is it?
I'm not sure.
Okay.
By this
Describe their emotions. Did anyone look angry, upset?
No, I think we were working on something.
Ah.
Like bio.
Ah. No message from him. Okay, what's this? Can you, do you have this, Michelle? You type it?
Do it random, by the way, 2.58.
2.58 sounds about right, yeah. Yeah. Sabrina, I know this one is a little bit harder than for you than for the other two there. I don't know if you missed this lesson or what, but is this okay or is there anything confusing here?
No, what you did right now makes sense.
It's okay?
Yeah, I know. And then you're going to give us another test and I'm going to be like, I don't understand what this is. I've never seen this.
You didn't miss this lesson, did you? Yeah, was it this one? You watched the video? Okay,
Yeah.
okay.
Yeah, Mom wanted to
do you-
you missed an important one today, so go watch the video.
Do you have these rules in your book?
Yes,
Because you
yes,
have
I
them.
have all
This is
the rules,
okay.
yeah.
So I think this is rule number 3 or something, where you can take the power down. Okay. So you're getting a sneak peek then, Ray, on what's coming up next then. 3D will do. Okay. Did you have class today?
Math?
Yeah.
No.
No, not on Fridays? Okay. 3 power minus... No, I'll do a different one. Let's see. I'll do...
You did the hardest one.
yeah, well, they're all about the same, but I think... I'll just do... J. Yeah, okay, J. That looks like a good one. J. So, 3 power minus 4x minus 9 equals 7 power 2x. Okay, Michelle, any ideas on what we could do first to this? No? Don't worry if you don't have an idea. It's just I like to work on this together, so
Can you bring the X down?
not yet. That would be later. Make what?
The base is
That's what Michelle said for the last question, but that doesn't work here.
Log.
Yeah, logs here, yeah. Why can't we make the bases the same? Yeah, that's it, to make it a 7, yeah. So, in that situation we have to use log then. So we'll put a log here and a log here. Right. Okay, so this is already looking familiar, isn't it? To the last one. Mariam, what do you think we could do next?
Bring the stuff down.
Yeah. So you get minus 4x minus 9 log 3 equals 2x log 7. Okay, Sabrina, any ideas on what we could do next here?
Divide.
We could divide.
Like switch sides, I think? No?
Yeah, no, we could divide by something, but maybe we'll do something else before that. Ray, any ideas on what we could do here?
No.
Michelle, you think you know? Yeah? Now go on. We're all working on this together now, so what do you think, Michelle? Sadly not. You can only cancel out logs when it looks like this. Log A equals log B. You're allowed to cancel the logs, but it doesn't quite look like that. Any other ideas?
We're just bringing the 2 over.
You take the log to the other side.
Yeah, that's what, who said that a moment ago? We will do that, but in one more step, just not quite yet. Yeah, that's it. This log 3 should multiply the bracket now. So it'll be minus 4 log 3 x, and then the next one is minus 9 log 3. Now, can you all see that? Mariam, can you see that, yeah? And Sabrina, can you see what I did there? I multiplied it in. So the log 3 multiplied these two things.
Okay.
Yeah, Ray? You don't seem happy with that. What do you think?
No, I'm good.
It's okay?
Yeah.
Alright. And this is 2. Now, I know it's 2x log 7, but it looks a little bit nicer if I write it as 2 log 7x. Because, you're multiplying. So, when you multiply something, you can change the order. Obviously. 3 times 5 is the same as 5 times 3. So I'll just change the order. It'll look a little bit neater like this, 2 log 7x. Okay, so what do we think we could do now?
Divided by 2 and 7.
Oh, so you get rid of this. I know why you're thinking that, because you just want x.
Yeah.
But there's also an x on this side. Ah, yeah, so now what could we do? So you have the right idea, you want to get x. But there's something to do before your division.
So we move to the other side, then make it all equal to 0.
Good, yeah. Yes. We don't have to make it equal to 0, but you do have the right idea. Move everything to one side. I'll move the x's to the right. So I'll have minus 9 log 3 on the left equals 2 log 7 x plus 4 log 3 x. Now, I just check, is that okay with people here? Is okay?
Yeah.
Yeah, sure? Okay. What could I do next now? What do you think? So you see, we kind of have 2 x's, don't we? Better if we had 1 x. Well, so what can we do about that?
Foil?
Say again?
Foil?
This is a word I don't know, maybe. What do you mean?
It's like you're multiplying them.
Possibly. Go on. Tell me more.
For example, it's like 2ln times 4ln. Then
Do you just 2 and 7 and half?
I think we're nearly there. Yeah. What do we do?
2 and 7, like what you asked.
We could do that. We don't have to. We could work it out. Yeah. Okay, let me just put it this way. I think the logs are distracting you. Okay. If I said I have 2x plus 3x, what could you write that as? Yeah. Now, how did you get the 5? Yeah, you add the 2 and the 3. Right? That's what you did. Now, nobody is unhappy with that. You're all happy with that. Okay, so keep that in your mind as we go back to this.
Add the 2 and the 4 and the 7 and the 3.
Yeah, 2 log 7 plus 4 log 3 x. Can you see how it's the same? Yeah. you were distracted by the logs. But you knew what to do, you just couldn't see it. Now we don't have to use the calculator just yet because there's one thing left to do. What's the last thing here? Remember, we're trying to get x after all. X equals, yeah, so
Would you bring the x over and bring the rest?
we could keep the x on the right, that's fine. What would we do here? Divide by what? That's it, the 2 log 7 plus the 4 log 3. Again, because if it was something like this, you know, if I said 6 equals 2x, everybody's happy just to bring the 2 down, right? This is not going to make anybody unhappy. So it's the same thing here. Same thing here.
And then we put that equation back.
Now we can, yeah. Now, Mariam, you said a moment ago we could work out these numbers.
Yeah.
You could, but you have to be careful. Sometimes in the exam they ask for the exact answer, which is the answer left like this before the calculator. If you use the calculator too early, you can never get this. Do you know what I mean?
Yeah.
So you have to be very careful that the question, if it asks you for exact answer, in fact you have to give the answer like this. This is called the exact answer.
If it's
Yeah.
not exact, then I'd have to.
You can get, no, if it's not exact, if they don't mention this word, you could give the answer as a decimal.
Okay.
And that means you could actually use your calculator earlier, if you like. Okay. Did anybody type this in? Michelle, could you type this in for us, please? Oh, you did. What did you get?
Oh, sorry, I mean, but on the calculator.
Yes. No, we'll do something number 4 in a moment. I don't think you have to use brackets for this type and be alright. Do you know how the calculator, Sabrina?
I do, I just.
At home as well?
But I did get the right one.
The Casio 990?
Yeah.
Okay, mine came yesterday.
Oh, you got yours from Amazon?
Yeah.
But then Mo got in my head and he said, no, use your other one for the exam. And I was
Which one?
The big one.
Don't listen to him. He doesn't know what he's talking about. Right, what?
I'm getting a negative.
Yeah, negative sign, yeah.
Minus 1.19.
Minus 1.19? Super. Okay. Right, 4. We'll do 4. We'll do 4e, we'll say. 8e2x plus 9ex minus 1 equals 0. Okay. Right, what to do here? So, anybody have any ideas on what we could do here? Not this time. Any ideas?
You added,
Go on, yeah?
negative 8
Yeah?
plus 9,
Yeah?
and then.
No. Okay, possibly if I use a little bit of colours here, it might help. I'm going to change this into this, ex squared. It is the same thing, because what's obviously 2 times x is 2x. So I know it looks a little bit different, but it is actually the same thing. Plus 9 ex minus 1 equals 0. Now, I don't know if you can see anything now. Now, I can make it even clearer for you. What I can do is I can say call. Come on, where's the... Is everything... Oh, there we go, there we go. Call ex, we'll just give it a letter, we'll just call it u, for example. So this becomes 8u squared plus 9u minus 1. Now can you see what's happened? What do we have? A quadratic, yeah? Can you see that? It's a quadratic. The variable is u. Yeah? You can all see that? So, we know how to solve quadratics. We even have a formula for it. We can say u equals minus b plus minus square root b squared minus 4ac all over 2a. So that's minus 9 plus or minus.
Yeah, that's a quadratic equation, was it? I don't know what the number is. Minus b plus.
Oh, the formula.
Yeah.
Yeah, I'll just write it here for you. You mean this guy?
Yes.
Yeah. Yeah. Um, 81 and 32, what's that now? 113? Yeah. So unfortunately this has a decimal. So we get u equals either something or something else. So Mario, maybe you could type in the +1, and Michelle, maybe you could type in the -1? -9 minus root 113? Yeah. You're doing the -1, and Mariam, you're doing the +1. Zero point.
10.
Okay.
That's the positive.
That's the positive one, yeah.
Yeah.
And Michelle, have you got the negative one there? Yeah, the answer is probably negative.
It's minus 1.23.
Okay. Strange.
I did on the plus bracket.
Oh, okay, alright, grand, okay. Yeah, no, that seems right, yeah, okay. Now, we're not quite finished, because what did we work out here? U. But what were we looking for at the very beginning? We're looking for x. Right? We didn't want u, we wanted x. So, Mariam, do you have an idea here? What could we do to get the x? What do you think?
Wait, what?
Here we have u,
Yeah.
but we didn't want u. What did we want at the beginning? We wanted x. So we're not quite finished. There's something to do next.
No.
It's
No.
such a good answer.
No, not log, I'm afraid. Not log. How can we switch it back to x though, you see? Because we have u, but we actually need x. Yeah, use what? What do you think, Michelle? It's a substitution, yeah, it is. Where though? Yes, yeah. Yeah, it's here. You see, because you can sub these values back into this guy. Because you can now say EX equals 0.10 and EX equals minus 1.23. Yeah? Does that make sense for you guys? Mariam, are you sure? Too much sunlight, is it? I don't want EX, I want X. So, how do we cancel E? With a log, yeah. So, we'll put a log here and a log here. a log here and a log here. So, logs and e's cancel, alright? So that guy cancels that guy, and that guy cancels that guy. So you're left with x equals log 0.10, and x equals log minus 1.23. Now we have a problem with one of these answers. Which one is a problem? Yeah, why is that now? Well, because we can't take log of a negative. So we have to reject this one here. And this answer we accept. So whatever that is, please. Michelle, log 0.1, please.
I don't understand why we can't put up log e.
Yeah, why do these cancel? Yeah, it's like a rule nearly. You know, like for example, square root and x squared, they cancel. If you multiply by 2 and divide by 2, they cancel.
Yeah.
The way you cancel an e is with a log. They cancel. So for example, if you had your calculator and you typed in log E4, I know you will get 4 as the answer.
Oh, okay.
Because they have a cancelling effect. They cancel each other. Likewise, if you typed in E log 4, I'll know you'll get 4. Because again, e's and logs cancel.
So it's just a rule.
So yeah, it's just a cancelling rule, yeah. Okay. Do we have this written down? Yeah? Okay, good. I just want to skip 5 because it's not so important for you right now and for the exam. But what is much more important is number 6, which I want to make sure we do. So, a good question that would be like an exam question would be something like 6H, for example. You know, that could easily be a section A question in the exam. So let's have a look at that. Can I scroll down? Yeah. 6H. We have log base 2 of 3x minus 2 plus log base 2 5x minus 1 equals 6. Okay, so before we start, we need to check what values of x we can use. So if you look at this one, we need 3x minus 2 to be positive, because we said we can't have log negative. So if 3x minus 2 is positive, then what should x be bigger than? So can you do this in your head? You bring the 2 over to the right. Can you all see that? Can you all visualize that? The 2 comes over to the right, and then what's after that? Divide by 3. So x should be bigger than what? 2 over 3. You do the same thing here. 5x minus 1 should be bigger than 0. So what should x be bigger than? 1/5. Yeah? Now, this is the hard part, okay? You need x to be bigger than 2 over 3 and bigger than 1 over 5. So how could you have those two things at the same time? Now I can give you an easier example first, okay? If I said x should be bigger than 6 and it should be bigger than 7, then how can I have both? I can have both by saying x should be bigger than 7, because then both can be true. So what about here? X is bigger than 2/3 and bigger than 1/5. How can I have both at the same time be true?
X is bigger than 2/3.
That's it, yeah. X is bigger than 2/3. Okay. So whatever answer I get, I need my x to be bigger than 2/3. So if my x is not bigger than 2/3, what do I do with this answer?
Reject it.
Reject it then. Okay, good. Alright, can I scroll down a little bit? Yeah. Right, now, this question here, you need to have your rules of logs. So if you don't know them, you should open them up in your notebook. What rule could I use first here? You can check your notebook if you like. Which rule could I use here? I think I have 6 rules altogether.
Well, I didn't take the rules of law.
You don't have the rules, that's okay. We can see if these guys know.
No, those are my other ones.
Then you have them up here.
No.
Michelle, you have your rules? And Sabrina, you have them?
I do.
Yeah?
Yeah.
So which rule do you think I could use first here? The first one, yeah. So the first one is log A plus log B. What does that equal, according to the first rule?
Log 2.
Yeah, like, I think, did I use A and B or X and Y in my rule?
X and Y.
Yeah, so log X plus log Y, what does that equal? It's log XY. Yeah, so here, this would be log 2, 3x minus 2 times 5x minus 1. That's the first rule. Can you see how that's the first rule, Mariam?
Log X plus log Y.
Equals log xy.
Okay,
You can see how
yeah.
that's that? Equals 6 here. Yeah? Alright, now what to do next? What's next? It's not a log rule, so it's something we can do here. Multiply the brackets, yeah. So log base 2, that would be 15x squared minus 3x minus 10x plus 2 equals 6. Log base 2, 15x squared minus 13x plus 2 equals 6. Alright, now it's getting a bit tricky because it's not clear what the next step is. What could we do next?
Do you bring the 6 and the 12?
Yeah, kind of, but how can we do that?
Get rid of the square.
Not this yet, no. I need a way to get rid of the log, actually. How can I do that?
Log.
Log can't get rid of log.
What can you do? How do you get rid of it then?
That's what I'm asking.
Okay.
Yeah. How can I get rid of the log here?
An E?
Nearly, yeah. So Ray, not Ray, Ray,
Right.
I was right the first time. Suggested E. Now the reason you suggested E was right in the previous one. So if you wanted to get rid of a log base E, you could use an E. So if you want to get rid of a log base 2, you can use a 2. So you put a 2 power and a 2 power. So 2 power cancels log base 2. And you get 15x squared minus 13x plus 2 equals 2 power 6. 2, 4, 8, 16, 64. Yeah? Continue? Yep.
Now you need to say.
Yeah, that's it. Remove this to the left, yeah? So you get 15x squared minus 13x. 2 minus 64 is minus 62 equals 0. That was 2 power 6. Yeah. You're checking this quadratic formula, Mariam? Yeah, so what do we get for x here?
We get 2.51
2.51 or?
minus 1.65.
Okay, now what did we say at the beginning? X should be bigger than?
2/3.
So, what do we do with, which answer do we keep, which do we reject?
Well, you reject the negative.
Yeah. So this is the answer. X is equal to 2.51. Yeah.
Everything is very understandable now, but like Sabrina said in the test,
It's a function of maths teachers to make it seem easy in class, but difficult when you try it yourself.
Yeah, that's on the midterm, I know there was that, and I was like, I did all these at home, and now I have no idea what any
Yeah.
of it is, like.
The only way to help that is with repetition. We'll just keep practicing, you know. I'll have to finish there a little bit early, so I'll make the test available until 8. And Ray, if you want, you can give it a go. It's not going to make your situation any worse, okay? It can only potentially make it better. Yeah? Alright.
Thank